Assalamualaikum. We are going to present our maximum and minimum problems. Our group members consist of 3 people: Aqilah binti AHMAD Raslan, NISA FARHANA binti MOHAMAD FADIL, and DINI NABILAH binti DZUL HAMIZI. Many application problems in calculus involve functions for which you want to find maximum or minimum values. The restrictions stated or implied for such function will determine the domain from which you must work. The function together with its domain will suggest which techniques is appropriate to use in determining a maximum or minimum value. There are 3 techniques: the extreme value theorem, the first derivative test, and the second derivative test. So, what is differentiation? Differentiation means the rate of change of one quantity with respect to another. One of the important concepts in calculus is mainly focused on the differentiation of a function. The maximum or minimum value of a function, the velocity and acceleration of moving objects, and the tangent of a curve are determined by differentiation. The differentiation is represented as f prime x or dy over dx. Next, why we use maximum minimum problems? The process of finding maximum or minimum values is called optimization. We are trying to do things like maximize the profit of a company or minimize the cost or find the least amount of material to make a particular object. These are very important in the world of industry. So, there are 5 steps in solving maximum minimum problems. Step 1 is develop the function with one single variable. Then find the first derivative. The third step is let the first derivative equal to 0 and solve for x. Step 4, find the second derivative. And the last step is substitute the value of x into the second derivative.
The question is, a closed can in the shape of right circular cylinder of radius r meters and the height h meters has a volume of 16 meter cube. A. Express the surface area A in terms of r. B. Find the radius of the can so that the total surface area shall be a minimum. In order to solve for the question A, we need to find area of the cylinder. The formula is 2 pi r square plus 2 pi r h. This will be our first equation. So, after we find the area, step 1, develop the function with one single variable. As you can see, we have 2 different variables, which are r and h. Hence, we need to replace the h by using the information given. Because the question is to express the surface area A in terms of r. If we take a look at the question back, volume is equal to 16 meter cube. The formula of the volume is pi r square h. We can conclude that pi r square h is equals to 16. Then, we bring pi r square to the right hand side, it will become 16 over pi r square. H is 16 over pi r square. Next, we move to question B. Find the radius of the area of the can so that the total surface area shall be a minimum. We already solved for the step 1 earlier, which 2 pi r plus 32 over r. Our second step is to find the first derivative. A is equals to 2 pi r square plus 32 r power of negative 1. In order to differentiate this equation, we can multiply the power with the constant and the index will be reduced by 1. Hence, derivative A with respect to x equals to 4 pi r minus 32 r power of negative 2. Or I can make it in the form of 4 pi r minus 32 over r squared. Step number 3 is let the first derivative equals to 0 and solve for the r. First derivative is 4 pi r minus 32 over r squared. To get the common denominator, we need to multiply the equation with r squared. Now, we will get 4 pi r cubed minus 32 over r squared equals to 0. Then, we multiply the denominator with 0. Now, we will get 4 pi r cubed equals to 32. We bring 4 to the right hand side, 32 over 4 will become an 8. The equation now is pi r cubed equals to 8. We bring pi to the right hand side, so r cubed equals to 8 over pi. Finally, we bring the third root to the right hand side. Hence, r is 1.366 meters. Step 4 is find the second derivative. So, our first derivative is 4 pi r minus 32 r power of negative 2. Same as finding the first derivative, we need to multiply or bring the index up front and reduce the index by 1. The second derivative of a with respect to x is 4 pi plus 64 r power of negative 3. The last step is substitute the value into the second derivative. When r is 1.366 meter, the second derivative of a with respect to x is 4 pi plus 64 over 1.366 power of 3. Then we will get 37.675, which is greater than 0. So we can make the conclusion that r is equals to 1.366 meter is a minimum value.
So for the question 2 is which is area of glass window frame is in the form of a rectangle at the bottom and semicircle at the top that has a perimeter of 4 meter. Find the value of x that will maximize the area of the glass window. Hence, find the maximum area of the glass window also. The area of glass window frame is A equal to 4x minus 2x square minus 1 over 2 pi x square. So that's the question for number 2. Step 1. We need to develop the fx with one single variable, which is the area that given in the question above, which is A equals to 4x minus 2x square minus 1 over 2 pi x square. Step 2. We need to find first derivative from the area given above, which is A equals to 4x minus 2x square minus 1 over 2 pi x square. We need to differentiate this equation, which is 4x become 4, negative 2x square become negative 4x, and negative 1 over 2 pi x square become negative pi x. For the step 3, we need to let the first derivative equals to 0 to solve for a x, which is let dA over dx equals to x, which is 4 over 4 minus 4x minus pi x equals to 0. And we brought the 4 into the another side. It becomes negative 4x minus negative 4x minus pi x equals to negative 4. And we factorize the x, become x in bracket negative 4 minus pi equals to negative 4. And the answer for x equals to 0.56 meter. Step 4. So for the step 4, we need to find the second derivative from the first derivative, which is dA over dx equal 4 minus 4x minus pi x. So for the second derivative is d square a over dx square equals to the 4 becomes 0, and the negative 4x become negative 4, and negative pi x become negative pi. So the answer is equals to negative 4 negative pi, which is negative 7.142. For step 5, for the last one, we need to substitute the value into second derivative, which is we find that negative 7.142 is less than 0. Therefore, it can conclude that x equal to 0.56 meter is a maximum value of area of 4x minus 2x square minus 1 over 2 pi x square. So when x equal to 0.56, we need to substitute 0.56 into the second derivative, which is become to a max equals to 4 in bracket 0.56 minus 2 in bracket 0.56 square minus 1 over 2 pi in bracket 0.56 square, and it becomes equals to 2.24 minus 0.6272 minus 0.4936, and it equals to 1.302. So the answer for the question 2 is A max is equals to 1.302. That's how we answer for this question.
Last but not least, after solving 2 questions, we can conclude that application of derivation is an important concept for solving maximum and minimum problem. The step used to solve the given question is to find the first derivative, then let the derivative equal to 0 and find the value of the variable. Next, find the second derivative. If second derivative is more than 0, it is a minimum value. If it's less than 0, it is a maximum value. A minimum total has been found by substitute x value into surface area equation. So that is all from us. Thank you.